So when I volunteered to give this talk, that was quite a long time ago, a few months ago. But since then, Oracle made an announcement. I don't know if you guys have heard about that. So basically, the announcements, they said that they made a mistake and they are going to stop shipping serialization by default in the next version of Java that you will have to enable. So because of that, I think we can all agree that we don't need this talk today, and I'll give you 40 minutes back. Thank you. Unfortunately, I'm kidding. It's still an issue, and we'll see why. So I put here, I'm going to start with a definition of, taken exactly from the OWASP 10 2017. So number 8.8, insecure deserialization. And there are a few things I want to comment here. The first one maybe is the fact that they talk about impact, right? So myself, I do a lot of security assessment, and I always have a hard time when I find a deserialization issue to set a severity to the findings, right? Because as they mention here, the worst case scenario is a remote code execution, but you never know, right? And I will explain that later on. So it's always hard to assess, to set a severity on findings like that. Another interesting item here is the fact that they mentioned that some fair amount of manual work is required to find these vulnerabilities. And I think that's a little bit misleading. I think you can automate the finding insecure endpoints that take your input and disregard. That part you can automate, but the part where you cannot automate or very difficult to automate is the exploitation, right? And I will explain that. So it's this thing. Yeah. There's that. So the reason why I've always been interested in this kind of vulnerability is that for a long time it's been nobody would talk about that, right? Until 2015, I think that was the key element that made people start talking about it. And these were people from IBM. They found a way to bypass some Android security just using Java deserialization. And maybe you've heard of this other one in news, where one of the transit company in the Bay Area in San Francisco called Uni got hit by malware, a ransomware, and the root cause of that was an unpatched WebLogic server, and the criminal gang they used that to get some money out of it. So, serialization means different things to different people, right? So, we talked about that before this, just before this talk. Typically, it applies to Java, .NET, PHP, Python, and I've heard Ruby, maybe. But not only it exists in different languages and different frameworks. We also talk about JSON deserialization, or XML deserialization, or YAML deserialization. So all of these are very different in the way they are exploited. So in the interest of time today, I will only talk about Java native deserialization vulnerabilities, right? So the way you exploit it, even though it's the same ID in every other languages, it's pretty unique in Java, and I will explain. So I have a simple example and a simple demo where I use this class, very simple class. So it's a bicycle class, it has a name and 2 integer members, and it implements the serializable interface. So this is our starting point. This is our simple class that we're going to use throughout this presentation. So what is serialization? It's very simple, right? You have a live instance, like a bicycle, and you want to dump it in binary form. That's the serialized part. The deserialization, obviously, is the parsing of the binary to reconstruct the live instance. So important things here, ACED0005. When you see that on a pickup or maybe base 64 on the web app, that means there is Java serialized binary being transmitted. Also note that, as I will explain later, the binary carries both data and metadata, right? So we see here at the top the name of our class, bicycle being, right? We see the name of the members, number of riders, etc. And at the end, we see the data, the actual data, fat byte, the name, and maybe some integers there. So keep that in mind. So native serialization is just that, right? Converting an object graph to a binary string. And it's used for persistence, to save instances in a file or in a database. It's also used for transmission, and RMI actually is a feature of Java that uses that mechanism to transfer instances across different nodes. So from a Java API point of view, you would serialize by writing to an object output stream class, and you would read from an object input stream to deserialize, right? So Java knows how to deal with native type like integer, float, and it also uses reflection for any custom classes. So for instance, our bicycle being class, when Java tried to deserialize that, you will load the class and you will see, okay, you have one string and two integer, and they will then continue the parsing based on that. But contrary to common mistake that often people make, no constructor is involved when you deserialize, right? So there is a mechanism in Java called unsafe. I like the name. So it's a way to construct an instance directly using pointers and the underlying mechanism without actually calling the constructor. And luckily for us, for our attack surface, not every classes can be serialized, right? So you must specifically implement the serializable interface. That's why in my first slide I had this implement serializable for the bicycle beam. So this is getting to the important part for exploitation. So, there's also a special handling that has been provided in the protocol, right? And these are called read object and write object. So let me explain. So you see here a big decimal class, which is a standard class, part of the standard class library in Java. And here we see some code example, some snippet from that class where we see a read object methods, right? So this is the way for the developer of the class to provide a specific way of converting from into binaries, right? And in this example, we see that first they read all the fields by calling default read object. So that will be the same as doing the default deserialization. And then they added some input validation. If something is null, then they do something, right? That's fairly typical. And why is this important? That's the key to this presentation. If you have a class that declares a read object method like this, because it's designed to do custom deserialization, it will always be called when you deserialize an instance of that class, right? And that's what we're going to have used today. Any questions so far? No? So what could possibly go wrong? So an application is vulnerable if it meets two criteria, right? First of all, you have to be able to send binary data to it so that you can control what you send, and the service or the web application must take that and process it and deserialize it, right? That's the part that can be automated, I mentioned at the beginning. It can be automated to detect that you have that going on. But that's not enough. You also need some special classes on the class path on the server, right? That have an insecure or something inside the read object method that is automatically called that you might be able to abuse, right? So we can chain them, we can do whatever. We call them gadgets in reference to rock gadgets. And I mentioned read objects, but there are a few other ones. So collectively, we call the read objects and some other methods I'm going to define later, the magic methods. Doesn't require any mushroom. So these are the magic methods. So these 5 first one here, similarly, they are always, if it's defined on a class, whenever you try to deserialize an instance of that class, this will be automatically triggered, right? The code inside these. And then the last one, who knows what that is? Garth? Exactly, it's destructor, right? It's called on garbage collection. So whatever code you have inside the finalize can also be abused, right? Because obviously, like any other instance, eventually when you don't need it, it's going to be garbage collected and then the finalize will be called. So typically you have a class that handles files. In the finalize method, you will close all the file handles, right? One example. Already mentioned that. Whatever code you have in a constructor will never be touched by deserialization. You will never reach that code. So what do I mean by abusing, right? So when I'm looking at gadgets, I'm looking at anything that has a static impact, right? So that can be writing files, reading files, accessing a socket, injecting code if you're lucky, denial of service, very common. Or really anything like sometimes I find an XPath injection or a path traversal that can be triggered from deserialization simply because inside one of these magic methods, they act upon the inputs and they do something about it. So this is an example that we will use in our demo. So I have this class called unused bean with side effects, right? So we see that it's serializable. And why did I call it unused? I call it unused because really there is no legitimate use case for it, but it happens to be there on the server, right? Maybe it's a test, maybe it's a library, whatever. And why with side effects? I have here a custom deserialization because I declare a read object method. I call the default deserialization, right? And then I do something specific. So who can tell me what that does?
It's commanded.
Yeah, so it's an OS command injection. And because this is a private member of the class, if an attacker is able to serialize that, we're able to control the value inside the CMD string, send that to a server. If the server deserializes it because it's a custom deserialization, whatever this code will be executed with our input. Right? That's the key idea. So saying the same thing in a different way. Imagine in the middle we have our vulnerable web application that takes user input and deserializes it. So the first step is the attacker use his or her own computer and create an instance of unused bean with side effects. Either because they are guessing we have that on the server, this class available on the server, or maybe it's open source and they did an audit and they found this class. So they are able on their computer to instantiate an instance of that class and control the CMD string to whatever they want. Then they serialize it, they dump it to binary, and they send that to our web application. The web application takes the input, but obviously it's not expecting an unused bean with side effects. It's expecting a bicycle bean instance, right? So from a coding perspective, that looks like this, right? So we call the read object method on the object input string, then we cast it to what we are expecting, and then we do something with this bicycle, right? So behind the scene, remember that when I show you the binary form, there's the name of the class up at the beginning. So when the Java virtual machine parses it, it looks at the class name and then load the class from the class path. Right? And in this case, it's not a bicycle bin, it's an end-use bin with side effect instance because we cheat, right? We are the bad guys here. And the class is loaded. And because this class has a custom deserialization read object method, whatever is inside this method will be called, and there we are executing our OS command injection. So that's the main idea. And also, yeah, because we're casting here, eventually we'll get a class cast exception, but that's already too late, right? Because we already achieved what we wanted to do. Any questions on that? Garth, are you okay? Is it going? Questions? Yeah.
So what type of validation methods could you put in to contradict us?
I covered that in the second half of the presentation.
Okay.
No spoilers, no spoilers.
So I always like to put this slide up, not only because there's my name all over it, but because it shows it shows for how long this has been going on, right? So a guy named Mark Schoenfeld in 2005 gave a talk at Black Hat, just the same talk I'm giving today, right? So I think this speaks to the fact that we fail collectively at alerting people, alerting developers that this was a thing, right? Because only in 2015, some people like Frohoff, Florence, and Matthias Kaiser, they alert the developer community about this issue before nobody knew about it. But it was being exploited for a long time, right? So that's, I think, an interesting point as well. Now we come to the point where I do a little demo here. So I'm running a VM, which is not networked, as you see here. Because I know you guys like to play jokes. So basically, I made a little web application that is vulnerable by default, on purpose, right? So I have this bicycle bin I was mentioning before, and then I have a little JSP that takes user input and initialized it. I can show you. No, I cannot.
Really, it's not there.
Is that right? Yeah. So very simple for you guys, for those people who know how to read Java. So very simple, I have a form. I'm expecting a base 64 input. I'm decoding the base 64. And then I'm just calling the read object method on an object input stream that reads based off that input, right? So basically I'm just deserializing whatever people say. So don't do that. So I'm going to compile it. Come on, knuckles. Wrong port number. So it's a real label.
I think it's an IRC port, the browser won't let you use it.
So what?
I think browser won't let you because it's IRC port.
No, I think. Oh, it's a
It's
port.
your unsafe port.
You're right. Good point. Very cool. So now this is where you paste your input, and here on the bottom you will see the server response. So I have some pre-canned example ready of base64 input of serialized data, and they are in my test folder. Other resources. For instance, I have a fatback, for instance, B64, right? So if I copy this and paste it into my input field, here, click submit. Basically, the bicycle fatback was added, right? So now let's start something else. I happen to have some test files here that are called calc Linux base64. And I submit this. Oh, I got an error. But I got a calculator popping up. Of course, this is easy because it's always command injection. And like I mentioned before, the root cause of the problem would be, if I can scroll all the way down, I don't know if you can read that, but class cast exception, unused bean with side effect cannot be cast to bicycle bean. So, and also it's interesting to look at how it's implemented here, the stack trace. So basically that's what our demo. Any questions? Yeah, it's a calculator. Now, especially for Duncan, I'm going to talk about mitigation. So how many people are Java developer here? A few.
Sometimes.
Counts. So I'm going to throw some ideas, and then we will compare them, what the best mitigation is at the end. So mitigation number one, wait for Oracle. So like I mentioned at the beginning, apparently according to this leak, Mark Reinhold, the chief architect, would have said that they made a horrible mistake and they're going to deprecate it, and only people who are explicitly re-enabling it will be able to use that feature in Java. Of course, everybody made fun of them. But personally, I think it's still a small step in the right direction. Obviously, this is the long-term plan. But after that, I'm going to talk about what Oracle already has as a short-term plan for mitigation. So basically, the way this is also linked to another feature I really like of Java 9. It's called JPMS. I don't know if you've heard of that. You know, as a security engineer, we always talk about attack surface reduction, right? So an example is if you have a Linux server in production, you remove the service you don't need, right? For instance, you remove the print service or whatever. You only expose what you actually need for your business, for what you need to do. Or if you have a Tomcat server, you will remove the samples, you will remove the admin console. So this is the same idea, but for the Java packaging, for the Java runtime. So JPMS, basically you have two tools. The first tools you run against your deployment, and it will list what module of Java you've been using and what modules you don't need, right? And then you use that output and you run it. That is another tool that repackage the Java runtime to only expose the modules you need. So I think this is a great idea. It's the next step from what they did a few years back with the server JRE. So we know a few years ago they removed applets, for instance, from server deployment. So this is the same idea, but you can really tailor it to what you need. And I think that's great. But like I said, this is more like a long-term solution. And I'm quoting here Patrick Ray from Risky Business Podcast, who said, I love this, this is only a good strategy if Oracle also has a time machine. Yes, because we've seen a lot of services, a lot of products, a lot of libraries that rely on serialization, and even Java itself, some of the features. So obviously, we need something else. So idea number 2, sandboxing. So in Java, there is this concept of a security manager, right? So we could think, maybe we could deserialize the untrusted input in a code block that would be protected by a security manager, and we would configure that security manager so that we won't allow file access, we won't allow process creation, whatever. We only allow what we need, right? But I don't recommend that approach. First of all, because it's hard to fine tune, because I remember in the 90s running a firewall. You have, this guy needs port that port off, and then another guy called, you need to open that port and that port and that port. At the end, you end up opening so many ports that it's becoming moot. And it's a little bit like that, right? Because you run a security manager, and maybe you have a legitimate use case where you need to access a file, you need to do this, you need to do that. So it's really hard to strike a balance between security and usability. And the main reason why I don't recommend it is because there is it's not really broken, but there is still something you can abuse, and this is an example of my 213.444. I'm to vanity CVE, like vanity license plate. This is 4444. Because in this example, we see again a finalize. So finalize being the destructor, the code that is triggered when you garbage collect an instance, and we see a file gets deleted, right? So a malicious actor could have used that. But even if that would have been deserialized inside a code that is protected by a security manager, the fact that the file gets deleted long time after wouldn't help. Even if you wouldn't allow file deletion in your security manager, that will still go through, right? Because it's after, long time after you've been deserializing the instance. And then we came to this idea number 3, which is the input validation of the name of the class. So this is what I did, what I was working at IBM at the time. And since then, it's been used by various tools and also secure coding best practices. And it's a very simple idea. And as anybody who ever had done input validation, you have 2 ways of looking at it, right? Allow list and block list. Are you guys familiar with this? Yeah. So either you specifically define a finite set of what you're expecting and you just disregard everything else, or you block specific known values that you know are bad. Again, if you look back at the binary form, there is basically a specification for this, like a protocol that Oracle came up with back in the days. You can have a look at here. So if you were to write a parser for this, this is how you would do it, right? So first of all, you have the stream magic, then the version, OWASP 5. So this is the version of the protocol, not the version of Java, right? And then that's an indication that you have an object coming up in the stream. And an object is always followed by a class description. So this is important, and we are going to use that for validation. Because the class description starts with the class name. So the number of characters and the characters and so on. And we see it here, right? The bicycle beam. So it would be very easy to write our own parser and wait to get to this top level class name and decide whether it's what we expect or not. It's actually easier than that because there is an API you can use. So this is an example of an allow list using this ID, right? So the idea is that you create a subclass of the object input stream, and you're going to use instances of that subclass anytime you're reading serialized data that are untrusted. All you have to do is override a result class method, and this notion of class description I mentioned before in the protocol is going to be provided to you here as the desk parameter here. So all you have to do is call the get name on the desk and decide whether you accept or not. So in this example, allow list, anything that is not our bicycle being class, I throw an exception. Otherwise, I proceed by calling the same method on the superclass. So proceeding as normal. Block list, very similar, just the condition which is different. If the name is unused bin with side effect, I throw the exception. Otherwise, I proceed as normal. And this is the idea that Oracle came up with. So remember the mitigation number 1 was a long-term proposal. That's the short-term proposal, which is already available in this version of Java. So it started as an enhancement proposal, which is now implemented because it has been accepted. And it relies on that concept, right? And the reason why I like it is for 2 reasons, right? First reason is, in addition to the simple ID I showed before, you can select at which level you want to apply the feature, and I think that's really nice. It can be process-wide or for individual object input stream. And also, I mentioned that oftentimes there is the issue of denial of service, which you cannot really protect by a feature like this. So they also added that, so they have some limits you can configure in terms of CPU, in terms of memory, because a very prevalent example is denial of service by memory exhaustion, right? So you will have a typical example is that you have a hash table or something that you serialize. When you deserialize it, you read an int from the string, and then you instantiate an array of that int. So as a malicious actor, you just send a really high number, and the server will instantiate an array really big and blew up the memory. So that's nice. So not only you can select on which level you set the feature, but you can also add limits to prevent denial of service attack. And if you were to implement such a filter, you will have to return one of these 3 values. So Ernst said I didn't really like it, but it's just to be able to implement this multiple level thing, right? So you can imagine that at the process level, you are decided, but only at a specific object input stream level you can allow or reject a specific class. So this is an example how you would write it. So again, it's process-wide. So you set a property, JDK serial filter, and it's much more complicated than that. That's a simple example where you use the exclamation mark and then the name of the class you don't want, right? So it's a block list, and then you proceed normally. And in our example, if I would run the demo again with that property set, I will get something like this, right? It will be rejected, and this is what I mentioned about the limit in terms of resources. So that would work, but in general terms, which one is better, I think, allow list or block list when you implement it? Yeah, why?
Whitelist.
Because you don't know what you don't know.
It's an unknown unknown.
Right. So there are a few problems with block list, right? We don't know. We might have something that we don't know that has a side effect in there, right? And also there are known ways to bypass it, right? So this idea was first thought up by Alvaro Munoz and Christian Schneider a couple of years ago. The idea is that they found classes like this where they would provide custom deserialization with object, And inside, they would instantiate another object input stream and read from it, right? So even if you do the right thing and you put a filter, you would only put the filter on the outer object input stream. You cannot control the inner input stream, right? So that's an example of bypasses, and these are a few examples here, and that's exactly that, right? That theoretical example exists in one of these, and you see, so basically you instantiate a subclass of object input stream, and here it's like a decorator design pattern, if you wish. So this is still controlled by the attacker, and you can set explicitly a filter here, unless you use the process-wide filtering, right? That's what I like. So that will still work. Both at the, you will block the attack both at the outer object input stream and inner object input stream level. Of course, if you specifically set the filter yourself per individual object input stream, you will still be able to bypass if you have one of these classes or something similar. And another reason why using an allow list is hard, it's a little bit like the example of the firewall I mentioned. In a real life scenario, in an enterprise scenario, you just look at this employee example. So you will need to allow employee class, employment period, project class, etc., etc. So you end up with a growing list of classes that you need to allow, and you have to be certain that there is no side effects anywhere in these classes. And I'm coming to my conclusion here. So I hope I was able to convey that the fact that using native Java serialization is a serious risk. So just don't do this. I don't think it's worth the risk. If you can use JSON, for instance, instead. But in the meantime, if you're looking for a best mitigation for a stopgap implementation, I would suggest the GDP 290 with an allow list process-wide. And if you dare to click on it, this is a URL obfuscated that will take you to, or even worse, the QR code, that will take you to my slide, my video, and my source code. That's it.